Oh, we lost Scott. Since we lost Scott, I'm going to go ahead and do quick introduction. This webinar is sponsored by the Keeping Forests Collaborative. It's a group of made up of lots of other other organizations, huge range of organizations working to conserve the 23 million acres of forest land in the South. And the novel thing about keeping forests is that they're taking a system level approach to forest conservation. So taking everything that everyone's working on and leveraging it into a larger effort. And the goal of their keeping forests is to support private landowners in their continued ownership and responsible management of forest land. And that's through 3 different high-level strategies, from promoting traditional forest products to creating emerging markets and generating a critical mass of support. So along these lines, Dr. Layton will be talking to us today about mass timber, a great market, current and potential market for forests. So Pat, I'm going to hand it over to you.
Thank you. Can everybody hear me? I hope. Leslie, hopefully you can hear everything.
Yep, that sounds good.
I'm going to share my screen and get going here. Wonderful. Thanks very much for having me today. It's always a pleasure to talk about mass timber. And I'm going to add a little bit on about modular construction, which is another big item, and it's a growing item throughout the country. So we're going to talk a little bit about that and how utilizing wood can sequester carbon and is an important opportunity for us here in the US in climate change and other issues. So in 2019, I'm starting with this picture. I actually was in the building that's pictured here on the website, on the slide. This is a city in central China, and I visited there. And the building itself, the one that you're seeing here, is like one of 3 that have been built on this site. It is a mass timber building, a heavy timber building, and was built about 500 years ago. In the background of the slide, you can see this city of almost at least 5 million people on the other side of the river. It's actually on both sides of the river, but I think the justification or the juxtaposition of mass timber from the past as compared to concrete cities of today is an important one. And what we'd like to see is more timber that is in modern buildings and a lot less carbon if we're really concerned about fossil carbon getting into the atmosphere and impacting CO2, and then sequestering as much carbon both in the growing stock of forest as well as in the buildings that we occupy. So here are some of the latest buildings, including Nashville, Idaho. The lower center is Columbia, South Carolina. The lower right is the tallest building in the United States. It's going to be 26 stories in Milwaukee. The center or upper center is a university building at Wofford. And then the building in the upper right is a chapel here on my campus. And you can actually see a close-up behind me. That's my screensaver right now. So those are buildings that are just been completed or are nearing completion even as we speak. So for those of you who are not familiar, I want to give you a little bit of an idea of what mass timber is. It is a building system that incorporates one or more of the following products, and I'm going to scoot through these. Those are the abbreviations for what I usually say. So I'll scoot through these and show you them up close. The building that you're seeing in this picture is on our campus, and it's an outdoor recreation center for all of our students. It's set up to where students can go in and check out kayaks and canoes and paddle boards and camping equipment. And they also lead hikes and everything there. So we wanted a definite feel and look for our building, and I think we accomplished it. It is a mixture of glulam beams and southern yellow pine cross laminated timber. The tall feature in the left-hand side is the elevator shaft, and it's made out of 5-ply southern yellow pine cross-laminated timber. All of the CLT was manufactured in Dothan, Alabama. So this is an example of CLT. This is at the Redstone Arsenal, an Army base in Alabama. And this is CLT. This is 5-ply CLT going in to form the, I believe this is probably the 3rd story of a hotel. So this is the floor plate of a next story, but it's the ceiling plate of the story below it. And one of the beauties of CLT, and here it's used for both walls and floor system, is that once you get it in place, you can work underneath it. And most buildings that are traditionally built with steel and concrete, you really have to get the entire structure put together before you can use other trades. But with this, once you get a level closed off, your trades can go in beneath you and work in the lower floors while you're still going up with the upper stories of construction. And that makes construction go very fast. This is nail laminated timber. This is a traditional building material that's been used in many of our old heavy timber buildings. So if you go into an old building and look up, the 1800s to the early 1900s, if it's a heavy timber building, you may look up and the floor above you looks like 2-bys on edge, and that's exactly what it is. And they are nailed together. And this one is exactly that. It is in a building right now. This is the actual building that was being built in Minneapolis, Minnesota, and they actually did use nail laminated timber. This is the modern version of that. It is, or a newer version of that. It is Dow Laminated Timber. And in this case, they've actually curved the wood a little bit so that you get a feature on the ceiling above you. That side is actually turned downwards. What you do is you put the 2-bys on edge, you drill a hole, and then you insert a superheated hardwood dowel into the softwood. The dowel will then come through. It's lost its moisture content. It's down around 5%. The 2-bys are around 12 to 15%. You put the superheated dowel, low moisture content, into the hole. It will slide in, and then as relative humidity increases the moisture content in the dowel, it will swell to a point that it is locked in place and nothing will move. The beauty of this is that if you need to make a cut, you are not faced with a bunch of nails. You actually have dowels in place and you can cut right through that if necessary. This is our glue lam. Glue lam is a traditional material. We've been using it here in the United States since the 1920s, I believe. This is the Raleigh-Durham Airport. It has both straight and curved glue lam in it. It's a beautiful building showing off that excellent material that we find in glue lam. This, in some cases, is used in place of what was in heavy timber buildings, which were solid beams. We are now using glue lam beams in those places. So you will see them used as both post and beams in today's constructions. This is mass plywood panels, and they are really plywood that is laid down in about an 8-foot wide versus 48 foot long sheet. And so you lay out the panels of 4x8 long ways, and then you come back and you cross them crossways, and then you do that again. And so you're basically taking plywood, which is already cross-plied, and you're taking the panels and you're cross-plying them on top of that and gluing them all up together. It gives you incredible strength. Only one manufacturer is making this in the United States that I know of, and that's Ferris Brothers in Oregon. This is LVL, and the picture in the building is actually Parastrand lumber. Those are columns there. So there are several other engineered wood products that are out there and being able to be used and replace heavy timber in these large buildings, which give us the strength and durability that we need to build buildings with. So in the US, the first buildings have began around 2010, and the first one I know of is in Hilton Head, South Carolina. It is cross-laminated timber imported from Europe, and it was married with both steel and concrete in this house, which is on the beach at Hilton Head. And so it had to meet strict hurricane standards, and they were able to marry those materials up to make a very strong building that would withstand hurricanes if they came ashore on our coast. The growth was slightly slow at first. In 2013, there were probably less than 15 buildings built, and most of those were residences. They include, for example, a home, if anybody's a football fan, University of Houston's coach, Dana Holgerson, actually built one of the first houses in West Virginia when he was a coach there. That's the kind of house it was. So the growth in the Pacific Northwest jumped first, and I think that was aided by the fact that Canada was also importing this and looking at it and expanding in this area. And it's grown across the country and has increased significantly since then. And just to give you a fact, we went from about 15 buildings in 2013 to today. There are about 1,150 buildings, I think, either built or in construction or in the design phase and getting ready to be built. And so that's since maybe 2016. That's 2013 to now, sorry. So one of the things that we had to do was get building codes to accept these products, because we're talking about some residences. We're really looking at these mass timber building systems to replace buildings that are, let's say, 4 to 11 stories for a big majority of the buildings, but up to, like I say, 26 stories in Milwaukee. And with that, we're going to be in the commercial building code. So this is the international building code for commercial buildings. And they mentioned cross-laminated timber first in 2015. In their 2018 edition, they included more. And finally, in 2021, they set up 3 type 4 buildings for mass timber. And I'll show you those in just a second. And these codes have been published now, and we are seeing them spread across the United States. So some states like Washington and Oregon were able to incorporate this even before the building codes were published. My state here in South Carolina, we have just voted on as a building code community to adopt the 2021 code, and we expect to have it in place officially by the end of December of 2022. It has to go through our state legislature for a blessing, but we expect it to be in place by January of 2023. So it'll have a year to get and set up, and we'll be doing hopefully some more trainings and stuff for folks about that. Other states, Georgia has adopted it. I was in Texas. I know we have a couple of folks on here from Texas. I was actually in Texas in October, and I believe the city of Dallas has taken up the 2021 code. And it was only this summer that Texas as a whole moved to a much newer code as a whole, but I think they go city by city in most cases. So hopefully we will see more and more cities as we go across the next year or so. Although there are a lot of states that will take up codes again. They took up the 2018 code, and they won't take up again until the 2024 code. But there are ways around the code. I'm so sorry, I did not mean to go backwards. So where we are now is we have 4 type 4 buildings, and that's very building code lingo, but type 1 is non-combustible construction. So that's like concrete stadiums. Type 2 is also non-combustible and tends to be mostly concrete and steel. And then type 3 is what we usually think of as stick frame. And then type 4 has been heavy timber. And we've set up a type 4A, a type 4B, and a type 4C. And they vary by how much wood can be exposed. within the building type, but mostly they vary by the amount of square feet or the number of stories of each building. So type 4A goes up to 18 stories, type 4B goes up to about 12 stories, and type 4C goes up to about 9 stories. I think that's right on that. So those building codes are coming into play and will now be available throughout the United States. Again, we just did ours. I wanted to just show you that it's an important facet. And if you have never met anyone who works on building codes, they're a lot like standards if you've been ever involved in standards development, but it is a very intense process. I've spent a lot of time in South Carolina this year going to building code hearings and listening to people talk about is and shall and may and very detailed comments. But it's important that we have building codes to protect our building changes. And building code officials, like here in South Carolina, once a code has published, you can use that as an alternative means to most jurisdictions. So if you're in a different state, it's possible that you can go and use new data, new building codes once they're published as an alternative means. So this is an example of how we've progressed. I did this slide to highlight South Carolina, but the buildings that have been started or built in the nation are 576 buildings that are already built. And in South Carolina, we have 18 of those. In design, there's another 665 buildings. And in South Carolina, 5 of those buildings are in South Carolina. And actually 2 of them are on our campus. So it's really easy to follow them. And Woodworks, which is a group that I worked with a lot over the last few years, actually have lists of these so you can go see what's being built in your area. You can Google Woodworks mass timber buildings and you can come up with a map like this. And they change this map quarterly. So you're able to really key in and go into the map itself and then into the list of buildings. And in some cases, once they're built, they'll even show you pictures of the building. So this is going into the map itself, and you can see the ones that are built in this area. I actually included a little bit up in the Charlotte area. So it's really taken off. 2 in Columbia, those 2 buildings are both hotels. There is another building, a 3rd building in Columbia, and it's not on this map at this time yet, but it will be going up. So those are all important buildings that are out there and being done right now. So where are we building? And because when we're thinking about really changing markets for landowners and really impacting the world, we really need to see how much wood we can use. And we've been able and privileged over the last about 10 to 12 years to look at light frame multifamily, which can go up to about 6 stories, 5.5 stories, if you put it on a podium. And there's about 8 to 9 board foot of wood per square foot of building. And then that's one of the types of buildings that we look at, and we've used a lot of wood in. But when we start transitioning to what we might call more mass timber, you'll see more and more board feet per square foot of building as we use heavy timber and a massive amount of timber. Another type that's going in right now are steel frame buildings with mass timber floors. And you see they're going in from 9 to 15 board feet per square foot. And then you get post and panel buildings. So those are glulam beams with floors that are cross laminated timber or nail laminated or Dow laminated timber. They use 30 to 20 board foot per square foot. And then post and beams, where really no steel or concrete in there. Those are using 17 to 25 board foot of lumber per square foot of building. And then if everything is CLT, like all the walls are CLT as well as the floors, you're using your most wood in a building at about 30 to 45 board foot with a per square foot of building space. And I'm sorry, I keep using my medium mouse instead of my pointer. So sorry, appreciate it. Sorry for that. So those are really important building types. And when we look at what we're going to build there in terms of the number of buildings, the Softwood Lumber Board has done an estimate, and they've determined that the opportunity for growth, for really large opportunity for growth for wood and especially mass timber, is in the 1 to 12 story built environment. So buildings that are 1 to 12 stories. And the reason for that is we really don't build that many tall buildings in the nation. We have about 25 cities that are over 1 million people. And in there, you will find the really tall buildings, but most of our smaller cities are actually using smaller buildings, somewhere under 15 to 18 stories in their largest buildings. And in some cities, you're height limited to 4, 5, or 6 stories of buildings. So it really depends, but that intense area of 1 to 12 stories is where we're going to see a lot of our area of construction. And we believe that 84% of that construction is non-residential, so it'll be commercial space. And but 95% of the 1 to 6 story buildings that's going to be built, which includes residential and non-residential, will be wood. So that's a huge amount of wood. And they're looking at, Softwood Lumber Board projected that by 2035, we would have about almost 5,000 new buildings built with wood. I think that's going to be an easy reach. I think these are very conservative estimates that were done. And so given the amount of housing we're lacking, that may be a lot more residences, and we may see a lot more of these go up than we are seeing now. So when you look at that and you start forecasting the incremental demand for wood, you can see that they've built a base case, which is the solid line, a high demand case, which is the small dashes, and a low demand case, which is low dashes. Yeah, low demand. And we're looking at somewhere between 5 to 7 million in 2035 for increased demand of million board feet. And that's not a lot, in my opinion, when we look at what we're bringing on board. For example, in the South, we've just recently brought on board into the stream another 1 billion board feet in the last year. And that still is going to leave us with more wood in the Southeast than we know what to do with. So these are all coming out. So we are looking at an incremental opportunity for glulam and mass timber panel buildings of about 3.8 billion board feet of increased demand. And when we look at that in a regional basis, here's where the numbers lie and the total number of buildings. You can see the South is still where a lot of buildings are being built. It's where the growth of the number of people are. People are moving south, and we're looking at residences and non-residential buildings for over 2,300 in that 10-year period, with some increases, substantial increases in the Northeast. So no matter where you are, those are things that are out there. So what might influence the mass timber use? Well, one is that there are discussions in Congress and all over the world, in fact, about using, developing not only a carbon storage market for forest where they're sequestering carbon, but there might be an opportunity for, if you build a building out of wood and you are sequestering that wood and keeping it in a mass timber building, there may be an opportunity for you to be a carbon store or to participate in a carbon storage market. So this is one that's out there. Carbon treaties. There are carbon treaties that are going on with the COP26. We just saw a lot of discussion in Glasgow, Scotland about those. There are opportunities and discussions in Congress about carbon tax credits, that if you build with mass timber, there may be an opportunity for a tax credit. We see business policies changing. So with corporate social responsibility, and then environmental, social, and governance accounting for investors, that corporations are looking at how they can reduce their carbon footprint. And we are actually seeing large builders such as Amazon, Google, and others really moving into wood buildings and building with wood. And in fact, as many of you may have heard, Walmart's new headquarters are going to be built from mass timber that are going to be harvested there. The timber is going to be harvested in Arkansas and then manufactured in Conway, Arkansas by Structurland. It is a source of innovation, so there is a lot of research and development going on in this area. It does provide for modular offsite construction. So what you're looking at in this picture is actually another picture of our chapel, but all of the glulam beams came shipped to our site, put together already, and they were just simply lifted into place with very little construction going on. And then large panels were brought in of cross-laminated timber that are actually hidden. You can't see them in this building at all, but they became part of the moment frame, and they were quickly placed in, quick to put up in place, easy to construct. We're seeing now whole systems come in, either large boxes that can be done for modular construction where they're built in a factory and brought to site on a truck, or wall systems with both interior and exterior finishes on the walls brought into place and put onto these buildings. So really building in a factory and delivering to a site is growing in popularity around the country. For example, again, I'll use Texas. When I was there, I was giving a presentation and I found a newscast about a house in San Antonio, and it was built from 3 components that were brought to the site on trucks. All the interiors and stuff were constructed and placed on the site, and these people had moved into this house. Well, I was with some friends from the Texas Forest Service, and they were like, where is this? Where is this? And it turned out it was a company in, I think it was Navasota, which is where I think the old racetrack used to be. There's a company there that builds wood modular construction for homes, and it's not trailers. This is not what I'm talking about at all. This is very high quality construction in a factory, and deliver it to site, put the building components, the boxes together in a way that forms the basis of the house. And basically they were just putting the skin on it when they got to the house. There's also, if we see the oil and gas industry continue to rise, one aspect of the use of cross-laminated timbers is to use that in place of utility mats, or for heavy construction, for laying down for mats for equipment and stuff to go over. We've also seen mass timber used in bridges and bridge construction, along with glulam beams. And so with the new infrastructure bill, if we're on rural roads, a quick and easy way for us to get that kind of small strength and bridges we need may be to build the bridges off-site, bring them in and locate them that are wood, and finish them up on-site, and really do that very fast, in a very fast manner. So that's a new innovation that we're looking at as we're moving down the process. So I wanted to then say, do we have enough wood? And so we know that North American softwood sawmill capacity increased by 1.4 billion board feet over the past year, with the US South producing 1.1 billion, and the expanding capacity in the South by 5%. We think that we'll have another 1.6 coming on by the end of 2021. But from what the experts are telling me, that is not even going to touch the growth of the amount of wood we have in the Southeast alone. So we had lost a lot of wood mills in the Southeast in the years between 2007 and 2017. And you can see on this chart, the light blue is the US South in 2012. And then what we think the US South production will be in 2022. And it is now up there with the coastal West and moving toward the BC interior. And in actuality, the BC interior is probably coming down in numbers of production as we're seeing companies who are hit by beetles move their capacity to the Southeast. So just a good idea of who the big producers are in lumber. These are the top 10 sawmill companies, or companies that have sawmilling capacity and their capacity for increasing that. So a lot of them are here in the Southeast, but there are a lot of those that are global, or at least North American in their holdings, including West Fraser, and some of the others that are there. Canfor is another one that's not there, but is there. Now, where do we make these mass timbers? So the cross-laminated timber or mass plywood panels are at these locations. So these are the panel mills, and this includes the utility mat manufacturers. So there are 16 sites across Canada and the US that are producing now. And some of them, the orange ones, produce both CLT and glulam, while some of them produce just CLT. The green ones are not on here, but most of these mills produce the green ones also. And I don't know, oh, the only mill that's specifically green is in Illinois. The mat in Texas, the mill in Texas, which is labeled CLT, that's in Lufkin, and they produce mostly mats when they're open, but they are PRG 320, so they can produce building components also. And they have one standard size that is a little bit smaller than many of the other manufacturers. And then this is where we can make glulam and CLT. So blue is glulam only, and orange is glulam and CLT. So that has grown also with a lot of the CLT manufacturers adding glulam lines, or starting with glulam lines, either way. And so there is a large production of glulam here across the South. These are the glulam companies, in case you're looking for them. So what can landowners do as we move through all of this to help increase this move from mass timber? And it's kind of the theme of this series is to ask for wood. It is often that I find folks who are building buildings and they are working with architects and they don't make a distinction of the materials that they want in their buildings. And this is quite often. In fact, I have a friend who's a consulting forester, but he's also a county manager. And he was very involved in trying to build a new economic development building for their 3-county region. And he called me and he said, what can I do to get my building in wood? You know, because I think they're going to come in with brick and nothing else, or concrete. And I said to him, I said, just ask for it. And he's like, what? And I said, well, the architect works for you. You don't work for the architect. So if you're the building owner, all you have to do is ask for wood, and they should be able to find a building design that will work for you that is made of wood. It's also important that you do that with anyone you know who is building. So, for example, my church added on, and we did use a lot of wood, a lot of glulam beams in our building. But you have to advocate for that. If they're building a new school district, a school building in your area, ask them if they're building with wood, because with the exception of Florida, I think it's legal to build school buildings out of wood in almost all states now. And you can safely do this and do it well and have fire protection and durability and all of the things you need, and come in below cost for most school systems. The other thing is being an advocate is to make sure that if you can find a mass timber building near you, go visit it. pictures don't do them justice. And just showing off the buildings that we've done here to people has encouraged more than 20 other buildings to be built with mass timber. It really means that people have to understand what they feel like. They're not quite what you expect. A lot of people think they're going to be very old-fashioned, and they're not. They can be very modern. They can look very old-fashioned if you design them that way, but they can be very modern, very on point with any type of design and look that you want, but you need to be in them and feel them. And they do have, they're different. And so, like, for example, I had my students all go visit Andy's place right after it opened, and then they had to write up a paper about what they thought about it. They were all surprised that it didn't look like a log cabin. And they all commented on the smell. They said it smelled good. It smelled good, and that it was nothing, that they felt good about it. And why didn't they have that for the 4 years they've been at Clemson? Because these were a lot of seniors. They wish they'd had a building like that for the entire time they were here. So really getting in them and feeling them is something that's important to do. So I encourage you to go visit one near you. And then keep managing your forest, because what you're growing today will be in buildings before 2040, probably. There are a couple of key pieces, so I'm going to geek out a little bit on wood science with you. But when we're building with wood, anytime we're making good products with wood, we have product qualities that we like. And for structural wood, those qualities are determined by design standards. And I'll use Southern Pine, for example, but it's similar in other standards. You do not want a lot of knots, especially loose knots. You don't want any knots falling out, and you don't want knots that are an angle to the bole of the tree. So if I have a board that's going this way, I don't want a knot in the middle of it coming out, because that takes up more of the cross section of the board. So that means, as an old forest geneticist speaking, I want the angles of my branches to be at 90 degrees to the stem. I want the trees to prune well. So I want them to drop their lower limbs early on in their growth, so that as they grow, so if they're at like 4 inches in diameter, when they start dropping off those lower limbs, maybe they're even smaller, by the time they get to 10 inches, that means they've grown 6 inches of clear wood with no knots. And that's really prime wood. That's the high dollar stuff. That's what mills would like to make. And really, when you look at a mill, when they start they bring in logs and they start sawing them up, they make about 60% of their wood, their lumber that comes out, is going to be what we call prime number 1 or number 2, high quality wood that can be used in CLT, or sometimes, most of the time, in glulam. But that means that 40% of the wood that becomes lumber is not living up to that standard. And so what we'd love to see is that number to get higher and higher, and we have more clear wood, less knots, better straightness. So another thing we want is to find, if we are selecting species or varieties or, MPPs or just families, when you're trying to plant trees, go in and ask for really straight trees with low branch angles, with 90-degree branch angles. If you can find trees or families that are known to have high density, that's important too. And that has to do with number of rings per inch, because it really helps when you have a lot of late wood in an inch of wood. That increases the density. But density is based on both species, and within species, there is variability there, and also on the silviculture that you perform on it. So thinking about your silviculture and thinking about what you're planting, the families that you're planting, you can increase density. Density is extremely important. If you are near a sawmill that is buying your wood, that is then selling to a glulam manufacturer, glulam probably has the highest requirements of all the engineered wood products that we're making. Although laminated veneer lumber and plywood have also requirements that require higher density trees. So when you're thinking about what mill you're going to sell your wood to, what's your marketplace, it's important to know what their requirements are for wood. You can take smaller trees, 16-inch trees can certainly make 2x6s and 2x8s. And most of our glue lam and CLT is made from those sizes. Both the NLT, the DLT, all of the past panel products that I've talked to you about can be made with things that are saw logs. So we're talking, you could get some out of a 12-inch, you could get some out of a, certainly anything up. And most sawmills, about 90% of the sawmills today that are in operation in the United States do not take any tree bigger with a bigger butt end diameter, big end diameter than 28 inches. So we're not talking about really huge trees going into the production of this material. A lot of them will be smaller diameter sawmills because they are much more efficient. And so they are really pushing through the efficiency of those sawmills. And as we've made more efficient sawmills, we've actually decreased the size of the log that we can take into a sawmill. So that's important for landowners to understand what you can do to be an advocate for wood, and then what you can do if you're growing trees. And those are two steps that we can have a difference in that will bring more products to market and make a better quality mass timber building. So again, I'm giving you an example of two buildings on our campus. Both, this is the Andy Quattlebaum interior and exterior shots. And the screenshot behind me is the interior of our chapel. But what we've learned is that wood is universally beautiful to man, and it is the most humanly intimate of all materials that we can work with and build with. And that's why I think that all humans love to be in wood and have wood around them. And I could go into another talk about biophilia, but we've proven that wood and nature in the environment inside where we live, if we can see it or touch it or feel it or be with it, it reduces stress and makes our lives a lot more delightful to be in. So those are some terms there that are good reasons for having to do that. And again, Frank Lloyd Wright is one of my favorite architects. And when I found this quote by him, I thought, that does it, that says it, because that really is the essence of his design. So thank you for having me today. And I think we'll turn it back to Leslie for some questions.
Great, thanks so much, Pat. It was an interesting presentation and lots of great pictures. So we have a few questions in the Q&A, and I'm going to go ahead and read them off to Pat, and we will I'll have her answer as many as she can until we reach the top of the hour. And we'll respect everybody's time. So, well, one question I think was already answered, but I'll go ahead and let you answer it again. But there are CLT manufacturers in the South, and if no, why not? Or if I know there are some there, but why aren't there more?
Why are there more? Well, it's new. And so we have 1,200 buildings being built. So we have to keep up. We're keeping up. And it's about a $50 to $100 million capital investment to build one of these plants, depending on the size, but 50 would be a minimum and 100 million would be a second one. So there are the three main mills that are four mills. So Structure Lam, Texas CLT, Smart Lam all have plants, and so that's three plants that are already there. And then there are two that have been announced by Bender in their mills, one in Florida and one in North Carolina, that they plan to build. I'm not aware of other southern mills, but they have moved across. There are people considering them. Yes.
Great. And there was a question too, could you talk a little bit about the process for the mass timber building on the Clemson? And do you have to get special permission? Were they low bid, and did that make the difference? And I know you touched upon this, but just want to reiterate some of these points here.
So yes, so we built this, the one at campus, we actually built it as a type 3 because it fit into the type 3 category, and that was already a building code that we could use. And yes, we are a state agency, so it did have to be low bid. And one of the reasons that these buildings get low bid is because you can leave so much wood exposed that you don't have to finish. So the cost of sheetrocking a lot of that building it goes away. And we came in under with the building designed as we designed it. We were under bid. We were under the it was the low bid for the whole project by about $150,000 to $180,000 on the bid. And the bid came in about $500,000 below what was actually in the total amount of fundings, because they went out and built a beautiful little amphitheater outside the building with all of the contingency funds they had left over in the budget for it. So
Excellent.
it did come in really well and came in on time. So started in December, breaking ground 1 December, and we had an occupancy permit the next December.
Great. So there's a question about, using mass timber near where there's flooding from storm surges and where there are lots of wood boring insects. And someone asked, what would be your response to such concerns?
Well, my number one rule for my students is don't let it get wet, or at least don't let it sit in standing water. So you've always got to protect, and that goes for both steel, concrete, and wood. You should never, you're going to have to worry about all of these. It's a matter of a scale of time. Steel and concrete don't do well with a lot of those other things also. So it is important that you think about where you're building and how you're building. For a lot of things, a lot of these buildings are going in with a podium. So it is a concrete first floor, and they will go up with concrete beams to the top of the first floor. Our building is not, it's hybrid. So the wood doesn't start until the second floor because you have glue lam. The glue lam beams are being held up by steel posts. So you do need to think about how you enclose the building and protect it from insects, mold, mildew, and then also think about if you have exposed wood, will you have a mildew? But you can stain, you can treat, and you can clean a lot of this, but it will stand up. We've done some testing to look at wind speeds, whether they would stand up to the wind speeds of a hurricane force, and we can engineer that strength into the process.
Great. No, there's a question about, what are hardwoods place in mass timber, or is there a role for hardwoods in mass timber?
Well, Virginia Tech has been doing some research on that, I'm aware of, and there are opportunities. A couple of the things that we have to do is we actually have to have strength requirements in design or in the manufacturing standards so that we can grade the piece of wood to meet strength requirements as needed for structure. And then we'll take those strength requirements and grading rules that are developed for the wood species, and then you can test them in hardwoods. There are things that have been built with European beech. There is some ideas there. It's actually an elephant building in European beech in Zurich, Switzerland. I've seen things built with yellow poplar, but not structures that are long-term standing. But I know that they are looking at yellow poplar. I don't know that they're looking at others. And I do know that you have to marry the glue up and do the protection that you need to do on all those hardwoods. So yes, it can be done. And it may be a matter of time, and it may be a change in how we grade and manufacture hardwoods in sawmills.
Great, thanks. So there's a question too about if you could explain more detail on receiving carbon credits for use of wood in buildings, or what you know about that, because I know that market is rapidly changing.
The last time I looked into it was in September, and there was some proposed legislation, but I don't know that a lot of it has gotten through. So I'm going to say that I think it's been written into several items. And I think there was 2 senators. One was from Indiana, maybe Stabenow and Barr or someone else. Anyway, they had some discussion. They had some potential there in their legislation, but I don't think that legislation is passed yet.
Okay. Yeah, and I know from other sources, I've just, the forced carbon market is still very much the Wild West, and things haven't quite landed where they're going
And
to
for
land.
the ones in buildings, the tax credits are probably going to come first in a building. Although there is a company that's out there saying they're trying to create a carbon market for stored carbon in buildings. It's out of Colorado, but I
Okay.
don't know that they've done it or not.
Yeah, great. There's a question about what species of wood provides the best structural properties for compressive loads, like in the column, and what species for tensile loads in the beams, and any species that performs best in both conditions.
Because we have manufacturing standards for both, Doug for him for SPF, SYP, that's already built into it. So there is no best species. If they're making it with glulam, they've already assured you that if you buy a certain beam, you're going to get that. So there are design standards for each of those types of species. And I wouldn't say that any one is best. I will say that, I'm very partial to Southern Yellow Pine, and it is a very strong wood, and it does do very well. So
great. Let's see, what else do we have? Oh, there was also a question just about fire hazard and termite hazard and how long the treatments last.
Okay, so fire is the massive portions of the wood themselves begins to be our fire resistance mechanism. So wood is combustible, meaning that you can burn it, but it's fire resistant. Steel, for example, is non-combustible, but it is not fire resistant. So when you heat steel up, it reaches a point at which it will lose all its strength and the building will collapse. So it's not fire resistant. The way that wood is fire resistant is the charring effect. So if you think about burning a log or a beam, it will form that black char around the outside of it. And then as it burns, it will only burn about an inch an hour. And so we can actually then say, if we want something to be 3-hour fire resistant and still have strength to hold up a building, we just add on extra inches of girth to that piece of wood. Mm-hmm. And that way we build our fire resistance into it. And it never went the way we design it. If it's a 3-hour fire resistant or 3-hour fire system, it can burn and still be strong enough to hold up the load at the end of 3 hours. Now, in most of the cases where we've actually done fire testing on these things, you really burn up the contents of a building first, and the fire will, in most cases, sort of put itself out. It will die back down once you get rid of all that fire resistant stuff or the fire consumption, like vinyls and cloth and paper and things that easily burn. And the fires will, in a lot of cases, burn themselves out. And wood is much stronger in that case. With steel, you have to wrap it in, you paint it with intumescent paint, which can lose its strength after 3 years. You wrap it in gypsum board. That gives it about 20 minutes for every layer of type 3 gyp board, type 5, one of those gyp boards. Mm-hmm. So it's a matter of you're going to deal with it one way or the other.
Thanks. Excellent.
And for termites, yes, termites are an issue if it's on the ground, but my house is made of wood. It has a brick veneer exterior, and I just do termite baiting. I mean, we have Termites come, and if you can, and there are a lot of old buildings that are still out there that have never had termite problems because of the way they're built and the way they're managed and how we do pest control in this country. Mm-hmm.
Yep, good points. Something to have to think about the old versions. There's a question too about, have you encountered wool cement products or wool cement products, WWCP, as a building material in North America? They're used in Europe and China, but the person has not heard of use of these in residential or commercial construction in the US. So wool cement products.
Wool is in sheep wool or
Well, sheep wool is the spelling.
Okay. No, I do know that there are new, and I don't know that I'm not familiar with that product. I do know that there's a lot of new things coming in insulation that are going to be cellulosic wool insulation. So they're made from trees, and there's a big plant going up in Maine that's going to be doing that. That is often used in Europe, but that's in an insulation mode. And that also, I think, is treated with boron for fire resistance.
Great. There was also a question about, let's see, someone asked if you had talked about the certified layups for CLT versus custom layups.
I'm not sure what a certified layup for CLT is. A custom, all CLT panels can be customly laid out. So how we do is, once you pick an architect and your engineer, you really need to marry up with your CLT, or be very aware of your CLT manufacturer, so that you can know what and how big and what size and which species and what they're going to use for your product. And to that extent, you can saw everything and get it cut just perfectly on their CNC machines. There are people, though, who build, for example, there's a company called Souter Timber. They buy CLT panels from Europe, bring them to their CNC machines here in the US, and then cut and design. So they're buying sort of commodity panels and then transforming them into buildings with their CNC machines. But I'm not sure about a certified layup. Do you have a follow-up on that?
There is not a follow-up right now. So,
Okay.
but I know these are a lot of tough questions you're getting too. So there was a question, about all the CLT being yellow pine. And then in reference to that, your discussion about how you grow the trees will matter to if you can use them for mass timber or not. Someone asked if, all these stagnant loblolly pine stands, can they be used for CLT as is, or would a grower have to start over? So basically, is our trees existing? Are they okay?
Oh yeah. Yeah. Our existing trees are good. Now, what I'll say is that if you're going to have beautiful wood up over your head, you may put uglier looking wood in the middle or on the top that's going to be covered by a coating, the floor for the next level up. But the ones that you want to see on the ceiling or the interior wall may be the prettier pieces, and they can sort by that. So no, we can use, if it is a prime, a number 1 or a number 2. So when you go to Lowe's and you see that this is prime 1 or 2, you really cannot use 3s and 4s today in CLT. And that goes along with the manufacturing standard that's been developed by the US and Canada. There, we use the same manufacturing standard.
Great. All right. Well, we are
strength. So it's all about strength.
Well, I'm going to say thanks to Pat for this great presentation and for answering all those tough questions. And just want to remind people that if you're trying to get continuing education credits for this webinar, please follow the steps. Also know that this webinar will be recorded and it'll be available at the same link within a couple days or so. So thanks again, Pat. It was a great presentation, and enjoyed everything. And if she has a minute, she may be able to answer some of the questions in the chat, but sorry, we didn't get to everything. Thanks so much, everyone.
Thanks, everyone.